Some people say there is no difference between a scientist and an engineer, while other people think the two careers are totally separate from each other. Scientists and engineers typically have strong opinions about what they do, which makes sense, since it involves discovering, inventing, and improving pretty much everything. The difference between engineer and scientist include: scientists are the ones who create the theories, engineers are the ones who implement them. They complement each other and often work together, the scientists telling the engineers what to make, and the engineers telling the scientists the constraints that said thing to be made doesn't meet. They are indeed different, but they work very close together. Scientists ask what happens and why in the natural world, while engineers use the answers scientists find to create new inventions and ideas, not in the natural world. Both are equally important, as without scientists, engineers would not create, and without engineers the research scientists do would be wasted. They go hand in hand. Quote, there is hardly any difference between the two. In the end, it is all mathematics and physics. Science is about knowledge and engineering is about invention. Science is a lot of high-level theory, and engineering is implementation and optimization. Often a computer scientist will come up with a plan that a soft engineer have to modify, because the theory is not realistic enough to be in production. Engineers deal with math, efficiency, and optimization, while a scientist deals with what is possible. A scientist would be happy spending $1 million creating a trinket worth $10, as long as it's good science. An engineer doesn't have that luxury. Computer scientist and software engineer, engineering is, in a way, more of a science than science itself is. There is something integrally artistic about searching for knowledge simply for knowledge's sake, as a scientist does, and something slightly less so about the functional, practical, minimalist themes behind most engineering. Science is more romantic, in a way, a never-ending search, engineering limited to goals, profit margins, and physical means. Quote, scientist focuses on the unknown while the engineer focuses on the known. We actually complement well when the engineers can overcome their ego. As we can see from the list of the Nobel Prize in Physics, we can already tell who inhabits that area. Scientists are the ones who start the process, and their work is sometimes theoretical in manner, but really exciting both mathematically and mystically. Engineers don't really need to go that far to serve their purpose. I seldom see an engineer who knows the strong force. Quote, engineers are trained for using tools, where scientists are trained for making them. Engineers are hard workers, where scientists are free workers. Engineers spend most of their time looking at a solution where scientists spend their time looking at the problem. Engineers always treat the disease, whereas scientists treat the root of the disease. Engineers are narrow-minded and scientists are broad-minded. Quote, scientists develop theories and work to verify them, engineers search in those theories to optimize things in real life. For instance, scientists may research and find out some properties of a material, while engineers look for how to utilize those properties in an optimal manner, while considering efficiency, cost, and other aspects of interests. There is an overlap between science and engineering. In fact, you may find an engineer who develops theories and a scientist who optimizes. Science explores the phenomena of nature and attempts to find the laws that govern them, while engineering attempts to use the laws of nature, already known, to replicate them in situations leading to usable end results. Management provides the logical framework, what and why, the strategy and when and how the operations, for our efforts through science and engineering. Hence, every professional is a scientist, engineer, and manager, with different proportions, depending on their job assignment or career choice. Then what is technology? Technology is an integrated outcome of science, engineering, and management, pertaining to the phenomena of choice. Nuclear technology is the integration of science, engineering, and management pertaining to nuclear fission or fusion. Automotive technology is a collection of science, engineering, manage efforts pertaining to automobiles, and hence include IC engine technology, steering and control technology. Engineers only learn a particular field in great depth. For example, a physicist will know Maxwell's laws and basic circuit theory, but an electrical engineer will have studied next to nothing but electrical phenomena for the same time. Engineering also crosses the traditional boundaries of science. Chemical engineers study the physics of chemical reactions on large scales. Both jobs are problem-solving jobs. Both involve design, testing, and innovation. Both can be research jobs involving the study of new phenomena. Engineers solve practical problems, scientists solve theoretical problems. A scientist is the one who explores the principles and the laws which are the outcomes of experiments made in the laboratories, whereas an engineer is the one who applies those laws or principles to the materials along with the economics to materialize the thought of the products. Further, we can say that the scientist is the developer of the concept, and the engineer shapes this concept to product. An engineer is the applied scientist too. Engineers apply known principles and data to design and construct equipment and systems. Scientists perform experiments to develop and evaluate descriptions and laws accounting for the behavior of the world around us. Scientists research, engineers build. A scientist is someone who's paid for doing research, to discover new things, to explore new frontiers. An engineer is someone who has studied the known facts and is applying them to make or build a product which is used or then sold, such as a building, a table design, a bridge, etc. The scientist may study the bridges that have already been built to see where their structural weaknesses are, and to come up with new ways to build stronger or more stable structures in the future. The new generation engineer would then study the new ways of improved building, then apply those new facts and methods to the new things he or she is involved in applying science to make them better than they were before the new scientific discovery.